the different types of nomenclature and stuff that we talked about?
Yeah, because it's still just a little confusing for me.
Okay, yeah, no problem. Let's go over some of that, and we'll start with maybe just a quick kind of review of the different types of sort of compounds that we talked about in terms of naming. And really, when we talked about nomenclature, it was really broken down into really two types of compounds. One is ionic, which is a metal and a non-metal together. And a reminder that, it is this situation here that we do have that transfer of electrons. And again, no sharing of electrons. And that's really where we get our cations that are positively charged because they lost electrons, or anions, which are negatively charged because they gained electrons. And that's different than what we talked about, which is our covalent compounds or molecular compounds. And these guys are typically non-metals together. And really, when we talked about non-metals, they basically will share electrons. So in terms of ionic, there's a few different sort of things that we saw that sort of go with ionic. And we kind of broke it up into a type 1 compound, which is, again, our metal and non-metal. And whenever a metal is involved, it is always really the most important one to look at. And the metal in a type 1 would come from group 1, 2, or 3, or would be zinc, cadmium, and silver. And again, what all those guys really have in common is they all have a fixed positive charge. So if you remember when we talked about naming, everybody in group 1 always makes a +1 charge when they do form a charge. Everybody in group 2 is a +2. Everybody in group 3 is a +3. Zinc, cadmium, silver, they are transition metals, but they do have a fixed charge no matter what the situation is. Cadmium and zinc are always going to be +2, and silver will always be +1. And then obviously these guys would be +1, +2, and +3, always, no matter what the situation is. And really, when we recognize the metal as a type 1, that's pretty much all you need to do. You just need to roll into the whole name of the metal, and then the non-metal there gets that IDE at the end of it. So again, that's why when we look at something like NaCl, we see Na, which is group 1. That tells us sodium chloride. Now, type 2 is pretty much the same deal. It's a metal and a non-metal together. Again, here, always the metal, the most important guy, and that guy would be a transition metal. Or just to the right on the periodic table, where we see things like lead, tin, in that general area. And what all these guys basically share in common is these transition metals can have a variable positive charge, which means in some cases, for example, it could be +1 or +2, the same element. And really, when we recognize that as a type 2 metal, we need to figure out what the charge is on it. And we could do that by looking at the non-metal. So we'll always know the non-metal's charge. And we could kind of work our way backwards. And the naming is pretty much similar. We use the whole name of the metal. We still do the non-metal with the IDE at the end of it, but we do use a Roman numeral in the middle of the two. And the Roman numeral is the positive charge on one metal. So if you took just one positive metal out, what the positive charge would be on it. And that's like we saw in that example earlier, FeCl2. We look at Fe, which is a transition metal, and we go, I'm not sure what the charge is. But when we look at Cl, we do know it's group 7, which means it has a -1 charge, and there's 2 of them, which gives us a -2. This would then be +2. And then the name would be iron, Roman numeral 2, and then just chloride. Remember that we do not use any prefixes on either of these type of names. So anything that involves a metal and non-metal should never, ever have a prefix. The one that should have a prefix is actually these guys, which are type 3. And those are the guys where we actually do use those prefixes like mono, di for 2, tri for 3. Remember a couple of things. We don't use mono on the first name, but we can use it on the second name. So if we had something like CO, that would be carbon monoxide. Again, 1 carbon. Don't have to worry about balancing charges or anything with this type. Just really need to say what's there. 1 carbon would be mono. We don't use it on the first name, so we just use the whole name. We can use it on the second name like we see here, and a couple of other considerations. Again, if you get a couple of vowels that back up to each other, we get rid of the vowel on the prefix, and AO, OO is sort of a situation that we do that. Kind of related to type 1 and type 2 in a sense. The other part that we talked about were these polyatomic ions. And these polyatomic ions are groups of nonmetals like NO3 minus that basically have an overall charge and a special name like nitrate. And because a majority of all polyatomic ions are negative, there's only really one that's positive, which is this guy, NH4 plus, and that is ammonium. But for vast majority of them will be negative, which means they really will hook themselves up most of the time with a metal. And that means you get a metal and a polyatomic ion together. We will follow the same kind of type 1 or type 2 rules. And we just use the whole name of the polyatomic ion. Again, we don't use prefixes here either with polyatomic ions. The only time that we would use a prefix with a polyatomic ion was if it's one of the ones from the list that actually has a prefix as part of its name. For example, I'm not sure if this one was on your list or not, but this particular one here, that is a polyatomic ion, which is known as dichromate. And we would use the di here because that's the actual name of it. So that would be the only place in sort of a type 1, type 2 polyatomic ion that a prefix would be involved if it actually is a part of the name of those polyatomic ions. Remember, the polyatomic ions basically end in either ate or ite, and that's sort of a good way to remember them. The only difference between the ate and the ite is the number of oxygens. So typically the one in a group of 2 that has the least number of oxygens should end in ite. The one in a group of 2 on that polyatomic ion table that has more oxygens that are related to each other would end in ate. So we saw nitrate, just like NO2 minus would be nitrite. Any questions first on the quick cliff note of the different types of naming, and then we'll do some examples here. Okay, so let's take a look at some here, and I'll give you some time to work on them here. Let me try to make up some here. Do a variety of different ones. Let's go with, okay, let's go with go with that. Let's go with that. Let's do that guy. Let's do this guy. Let's do let's do so for these guys on the left there, why don't you give the proper name? And then we also have to do it the other way. So let's do, I'm going to give you some names and you can give the formulas here. Let's do do iron 3 oxide. Let's do potassium cyanide. Let's do, oops, spell it right, maybe. Let's do phosphate. Let's do ammonium. All right, guys, on the right, let's do proper formats. So take us a few minutes here or so. Names on the left and formulas there on the right. Okay, so let's take a look, kind of see how everybody's doing here, make sure everybody's on the same page. So we'll start up here on the left. So remember, really the first thing you want to do when you're looking at something, and it can be really helpful, is to really try to identify what you're dealing with. And what I mean by that, are you dealing with a metal and a non-metal? Are you dealing with two non-metals? Are you dealing with like a metal and a polyatomic ion? So here, if we look at this, hopefully at this point, we could recognize this obviously as a metal. We could recognize hopefully this as a polyatomic ion. And remember, whenever a metal is involved, it is really the most important one to look at. And if you look on the periodic table for that metal, which is nickel, we will see it in the transition metal region. So when you see that in the transition metal region, that should tell you that it is a type 2 metal. It also should tell you that it could have a variable type of charge. And we do need to really kind of figure out what is the charge on it. So for now, we may not know what the charge is there on the nickel, but we will always know what the charge is on the negative guy. And again, from that polyatomic ion list, that is carbonate, which is CO3 2 minus. Remember, whenever we put two ions together, we need to equal 0. So that means that the nickel here does need to be +2. And we do need to incorporate that into our naming. So this would be nickel, Roman numeral 2. Again, remember the Roman numeral is the charge, not the actual how many you have or anything like that. And remember, when we are dealing with polyatomic ions, whether we have one of them, multiple of them, it doesn't matter. We just use the whole name of the polyatomic ion, which in this case would be carbonate. So that would be nickel 2 carbonate in this case. Any questions on that one there? Looking at the next one, following the same sort of pattern, we see Na, which is sodium and a metal, and we see O, which is a non-metal. So this is a metal, non-metal. Again, metal, the important guy here. That is group number 1 on the periodic table, which means it has a fixed charge. Also tells us it's type 1. Because of that, that is all we really need to name this. We don't have to worry about charges or anything like that. Because it's a type 1, we simply roll right into the whole name of the metal, which is sodium. The non-metal gets the IDE treatment at the end, and this would be sodium oxide. And again, because this is a type 1 ionic compound, even though there are 2 of them here, and you might have the urge to prefix that, you should not do it. So again, there is no prefixes, has no effect on this type of naming, regardless if there's 2 of them or 4 of them or 6 of them, or however many there are, it will have no effect on the name. Any questions on that? To the next one there, again, following the same format, I see copper, which is a metal. I see phosphorus, which is a non-metal. So this tells me it's ionic. Again, our metal, the important one here, That is copper, which if we look is right there next to nickel on the periodic table, number 29. That is a transition metal, which tells us it's type 2. Also, again, here tells us we may not know what the charge is. The 3 here is important in this case because we don't just have one copper, but we actually have 3 copper ions that we're not sure what the charge is. We do know that phosphorus, which is group number 5, has a -3 charge. And again, we see here that there's not just one of those, but there actually is 2 of them. So that allows us to figure out that the total negative charge we got going on here is -6. In this case, remember, we need to balance it out for these 3. That means in this case, each one is +2. +2 +2 is +4, and +2 is +6. So they balance each other out. Now we're ready to name it. Whole name of the metal, copper. Roman numeral here would be 2, not 3. Again, it is 2 because if we took out one of those metals, it is a +2 charge. We have 2 phosphorus, which doesn't matter because no prefix here. We just roll with phosphide, IDE, at the end of it. Any questions on that one? Rolling through here to the next one. Looking at Ca, which is calcium, which is a metal. OH is our polyatomic ion. So again, here we have a metal and a polyatomic ion. As everything above there, it is the metal that's the important one. Calcium, if we look on the periodic table, there is group number 2, which means it has a fixed charge of +2, which means it's a type 1 compound. And at that point, that is all we need. We don't have to worry about charges in this case. We would use the whole name of the metal, which is calcium. And again, even though there are 2 of these hydroxides, we still just use the whole name of the polyatomic ion, which would be hydroxide here. So this would be calcium hydroxide. Any questions on that name? Coming to our next one here, I see nitrogen, which is a nonmetal. I see oxygen, which is also a nonmetal. Both of those tell me that this is a type 3 compound. Remember, as we talked about when we were talking about naming, personally, type 3 is really the easiest out of them all, but it really is the place where some people make a lot of mistakes. Type 3 is finally the place where we do use prefixes because it's non-metal and non-metal happening here. The good news about that is we don't have to worry about any charges because there's no electrons being transferred. We're sharing electrons. We simply just need to pick the right prefix with the element name here. So the first prefix here should be tri for 3. We use the entire first name of the element that comes first in the formula. So this would be trinitrogen, the whole name there. We would then use the second prefix, which is 4. So that is tetra. And the second element does get the IDE at the end of it, and that would be oxide. This is one of those cases where we see that we get a and O type situation that's occurring with our prefix to our first letter. In this situation, we do drop the A. So properly here, the second word would be tetraoxide here, no A, and there would be trinitrogen tetraoxide. Any questions on that there? And lastly here, looking at this guy, I see phosphorus, which is a nonmetal. I see chlorine, which is a nonmetal. Again, that automatically tells me, just like the above one, we're into type 3 place. That is prefixes. We only have one phosphorus, and remember, one is mono, but we don't use it on the first name. So again, here for non-metal, we use the entire first name of the element, which is phosphorus. The second guy is 3, which would be tri, and the Cl then would be chloride. So phosphorus trichloride. Any questions on that one there? And lastly, I got one snuck up there in the top there. So we got, I'll just go with purple. So here we're looking at this guy, which is chromium, which is a transition metal. We see sulfate, which is a polyatomic ion. So again, because a metal's involved, we're going to default to looking at that guy first. Here, chromium is a transition metal, tells us it's type 2. So I'll just come over here. We got a little bit of room, I think. So we got basically 1 chromium. We have 2 of these sulfates, which is a polyatomic ion, SO4 2 minus, SO4 2 minus. Grand total of our negative charge is -4. Since we only have 1 chromium, in this case, it's actually +4, not 2. And in this case, the name then would be, find somewhere right here. We'll go down this way. We will go with chromium, Roman numeral 4 here, again, because of the +4 charge on the metal. And again, even though we have multiples of that polyatomic ion, has no effect on the name, it would be sulfate. Any questions on any of the names to the left there? Why I sort of broke each of these down, just to remind you as well that if you were asked to write the formula for the cation, that would be it for nickel, the first guy. This would be the anion, which is the negative guy. This would be the cation for this guy. This would be the anion for that guy. And again, cation, anion, and stuff. So any questions on any of those?
So for the type of, because you know how it's type 1, type 2, that determines whether or not for the Roman numerals that's going to be put as well. And then correct?
Yeah, I'm sorry, I didn't mean to cut you off. So for the for whenever a metal's involved, so you could really have what we talked about, sort of 3 places where a metal could be involved. You could have a metal and just a straight non-metal together. You could also have another metal and a non-metal together, or you could have a metal with a polyatomic ion. In each of those cases, it's always the metal that's most important, and it's the metal that determines whether or not you should put a Roman numeral in, or you don't need to put a Roman numeral. The ones that you don't need to put a Roman numeral are the type 1s. And those are the guys that have fixed charges, like in group 1, group 2, and group 3 on the periodic table. Because something, say, like sodium, no matter what the situation is, no matter who it's bound to, no matter what it is, the only charge that sodium will ever make is a +1 charge. And because it has that fixed charge, when you say the name of it, you don't have to tell a person, hey, sodium has a +1 charge. It's like common knowledge, like that's the only thing it could do. The difference between, say, sodium and the one above it, where we have nickel, nickel is a transition metal. And in certain cases, nickel can be +2, like we see here. Nickel could perhaps be +4, could be a whole bunch of other things as well, but it could be different types of positive charges because it's really a transition metal and has the ability to do that. And because it could have different types of charges, when you name it, that is the purpose of the Roman numerals, to tell the person, for example, in the first one, we're dealing with a nickel that has a +2 charge, as opposed to, say, we're dealing with a nickel that has a +4 charge. So that's what the Roman numerals for. And it's always the metal that determines, whether or not you need the Roman numeral. And again, if basically the metal comes from the transition metal region, or just to the right on the periodic table, where you see things like lead at 82, tin at 50, antimony at 51, bismuth at 83 on the periodic table, those guys which are technically not transition metals, but they also have the ability to make multiple types of charges and do need Roman numerals. Good. Okay. So then other questions on that there? Okay, then let's go to the right here and again, go sort of the opposite way. And remember, when you're going the opposite way, the name really does give you a lot of information. So for example, when I see something that says iron Roman numeral 3, what that really tells me is I have an iron and it has a +3 charge. That essentially is what the Roman numeral says. Oxide is oxygen from the periodic table, which is group number 6, which means it always has a -2 charge. So whenever we take a positive and negative guy together, we want to put it together in a way where we end up with basically no charge overall. The basic way you could do that is just simply look at 3 and 2. We can multiply them together. That gets you 6, which means if I take 2 of my irons that have a +3 charge and 3 of these guys that have a -2 charge, that gives me a -6 to balance out my +6. And now I could just write what I wrote there. I had 2 of the irons and I had 1, 2, 3 of the oxygens. And that would be the correct formula. We, by the way, know because we do see a Roman numeral here that this is a type 2 compound because the Roman numeral is stated. Any questions on that one? Now looking at the next one, which is potassium. And again, automatically I see potassium. I obviously don't see a Roman numeral. The reason I don't see a Roman numeral is because potassium is group 1, has a fixed charge of +1, which makes it really a type 1 compound. Cyanide is actually a polyatomic ion, and it is Cn-, which means ultimately here we're going to put something that is +1 together with something that is -1, which means when we do that, we really just need one of each of those, and that would give us KCN as the proper formula there. Any questions on that one? Again, coming to this guy, we do see, yeah, so you do have to memorize those polyatomic ions. They won't be provided for you. So I think there's a list that was in the notes or even online on Canvas. And again, a good way to memorize those polyatomic ions is to kind of group things together. Like I said, sulfate or sulfite. And sometimes people find it easier, for example, if you remember all the ites, for example, that means that all the 8s would be just 1 oxygen more. Everything else would be the same. So what I mean by that is if you memorize that if you would write, there goes, sulfite is this guy. And you're like, well, I want sulfate. That means that the only thing that changes is there's 1 more oxygen. So it will be exactly the same, exact same charge. The only difference is it has 1 more oxygen. Same thing if you remember that nitrite is this guy and you wanted nitrate, it's just 1 more oxygen. Add 1 oxygen, charge stays the same. So sometimes people will kind of memorize either all the ites or all the 8s and just know, okay, if I know the ites and I need an 8, 1 more oxygen, everything else stays the same in terms of the charge. If I memorize all the 8s and need an ite, you go the opposite, take away an oxygen. So again, that's a good way to sort of learn those names and stuff, is to kind of group them together like that. Other questions? Okay, then here we see type 2, as we do see a Roman numeral that is happening right there. And again, it also tells us really what we need. That's a cobalt with a +4 charge. And sulfide ID is not sulfate. It's actually just sulfur from the periodic table. And sulfur is group 6, which means it has a -2 charge. Again, we want to put these together to get no charge. So we actually need one more of the sulfide. That gives us a -4 to balance out the +4 on there. And now we could just put it together. We had just one cobalt, but 2 of the sulfurs. And now we would have the proper formula. And looking at the next one here, magnesium phosphate. So magnesium, again, group 2, which means it's really a type 1. I don't see Roman numeral either, and that is a metal. So I know it's type 1. That means when I go there, that's magnesium with a +2 because it is group number 2. Phosphate is one of those polyatomic ions, which is PO4 3-. So in this particular case, we're putting something with a -3 together with a +2. Again, 6 is our common number there. So if you think about it, if you just want to draw it out to visually see it, magnesium, to get yourself to 6, you need 2, that's 4. One more gets you a grand total of +6 happening. To get the phosphate to 6, you need 2 of them. And then we just want to write what we did. So we had 3 of the magnesium. So we write 3 magnesiums. Now remember though that when we do have more than one polyatomic ion in a formula, we do need to put parentheses around it and the number on the bottom as to how many we have. And that would give us the proper formula here. Again, if we wrote it without the parentheses, which would be incorrect, you would end up with something like this, where you're saying you have 42 oxygens, which is definitely not the case. So always when there's more than one polyatomic ion, you got to lay up those parentheses and the number on the bottom. Obviously, if you just have one, like we did here, you don't need the parentheses. So you don't have to put the parentheses unless you have more than one. Any question on that one? Lastly here, ammonium nitride. Ammonium is a polyatomic ion. It is the one few positive ones. So that is NH4+. Nitride IDE, most likely most IDEs do come from the periodic table. There are a few polyatomic ions that end in IDE, like hydroxide, but most IDEs are from the periodic table, and that's just nitrogen. That's group 5 that has a -3 charge. So in this particular case, we have -3 and +1. We actually need not 2 of these guys, but we need 3 of these guys. 1, 2, and 3 gives me a +3 to balance out the -3. And now, because I have more than one polyatomic ion, I would put that NH4 in parentheses with the 3 on the bottom. And as you can see here, I just have 1 nitrogen, which is what I would add to my formula. And then we would be in business there. Any questions on that particular one or any of the naming stuff? Hopefully this is a good review, I hope. So again, most very common mistakes is really, as I said a lot of times as we kind of went through it, prefixes. People for some odd reason feel like they need to use prefixes in every situation. And again, a reminder, prefixes should only be used in a type 3 situation, non-metal. Other than that, you really shouldn't be prefixing. I think people think it makes it sound more chemistry-like by just putting dyes and tries on names, but everything really does have its place. As you can see here, type 1, there's no prefix, there's no Roman numerals. Type 2, there's no prefixes, but there are Roman numerals. And type 3, there's no Roman numerals, but there are prefixes. So every sort of type 1, type 2, type 3 sort of situation has a specific thing that you include or don't include. And you never, for the most part, you'll never find anything where you are prefixing and Roman numerating at the same time. And if you do find yourself in that situation, there's a very, very high likelihood that it is probably incorrect. So If you find yourself on anything down the road here where you're writing prefixes and Roman numerals together, probably not correct. So again, everybody has sort of their own place. Any questions on any of that there? All right, so we're getting to the end of the discussion. So is there other questions I could answer for anybody?